Now, some other verifications besides just looking at the neighbors, looking at the show MPLS forwarding table. If we look at the show MPLS LDP discovery, this is going to tell us if we have any type of issues in the transport between the neighbors. So let's say, for example, that we forget to advertise our loopback into LDP. Or excuse me, not into LDP, but into IGP. So let's say we were to go to router 2 and we take the loopback out of ISIS. So in router 2, let's say show run section ISIS, and we're going to remove this passive interface. Okay, this now means from other devices like router 1, we should not know how to reach 2222. Same as from XR1's point of view. Show route IPv4 2222, we don't know how to reach it. But the problem we're going to run into when we look at this from a packet capture point of view and look at just our UDP traffic, we'll see that in the hello message that router 2 is generating, which should be like this one, router 2 is advertising its loopback 2.2.2.2 as the TCP transport source. But since this is not advertised into IGP, we don't have a route to it, it means that we can't actually form the LDP session. It's basically like saying, I want to peer BGP with you from my loopback, but you don't have a route to my loopback. It means we won't be able to establish the session. Now, in terms of LDP, one way that you can figure this out is to look at the show MPLS LDP discovery. So from XR1's point of view, show MPLS LDP discovery, and then it says there's no route to 2222. Same should be true from router 1's point of view. Show MPLS LDP discovery. Says we have no route. The end result of this is if we show MPLS LDP neighbors, we should see that eventually this is going to time out. Okay, right now they think they still have the session open, but they don't. Let's say clear MPLS LDP neighbor 2222. And we'll see now that the neighbor is down, the neighbor is not going to be able to come back up. There is a debug that will also show you this, which is the debug MPLS LDP transport events. Some versions of iOS will give you a specific error message here saying, I don't have a route to that particular destination. But I would say it's a little bit easier to troubleshoot this problem just by looking at the show MPLS LDP discovery. Because if you look at that and basically you could say show MPLS LDP discovery, pipe include route, and if there's anything in here that says I don't have a route to them, it means you're not going to be able to form that neighbor adjacency. Now, one of the other issues that could relate to this is that if you have an alternate loopback, like let's say we have loopback 22 with IP address 22, 22, 22, 22, and then we go to ISIS, let's say no MPLS LDP autoconfig. Okay, we'll enable passive interface loopback 0, which means that now router 1 does have a route to 2222. Show IP route 2222. Okay, we can reach it. If we ping 2222 from our own loopback, we should see that transport is working. Okay, but now from router 2's point of view, when we look at the show IP interface brief, it has multiple loopbacks. It has loopback 0 and loopback 22. If we go to the IGP process and now say MPLS LDP autoconfig, again, this is enabling LDP everywhere. So on any interface that we're actively forming ISIS adjacency, it's going to run the LDP process. And if we now look at the show IP route for ISIS, we see we have all of those destinations installed. If we look at this from router 1's point of view, we have the route to 2222, but we don't have a route to 22 because this is not advertised into the IGP process. If we now look back at the packet capture that goes from, or the hello I should say, that is coming from router 2, which would be this one here, router 2, and actually I don't believe it's going to do that because it had already chosen 2222 as the transport source. So let me do this. I'm going to have to do this kind of in a different order. On router 2, let's say no interface loopback 0. And now our router ID changes. If we look at the show MPLS LDP neighbor, it should say, or let's say show MPLS LDP parameters. No, LDP. LDP discovery. There we go. Okay, so this local LDP identifiers 22, 22, 22, 22. Okay, now we have the old loopback come back up, which is this one. And if we show run section ISIS, this should be advertised. Actually, it got removed. Okay, but let's say under router ISIS1, we have passive interface loopback 0. When we show MPLS LDP discovery, even though we have that lower loopback 2.2.2.2, the router ID does not change for LDP. So this means now when we're sending those hello messages, and if we look at the capture of these, we should see that router 2 is now advertising the 22 address. It says that's my label switch router identifier, and also that's my transport address. So from the other device's point of view, like router 1, we should be able to ping 2222, but not ping 22. Okay, and again, the reason is that I haven't advertised this into IGP. But from router 2's point of view, that's what it's using as the transport source. Now, the simple solution for this, like somebody mentioned here though, is that you hard code the identifier. So if the router ID was statically set to loopback 0, 2222, it means that the transport identifier also comes from that same address. And that's the default behavior, that your highest loopback becomes the router ID becomes the transport source. But technically they are separate values. Where we could go to router 2 as another solution for this and go directly to the interface, like interface gig1.12, and say the MPLS LDP discovery transport address we'll say is the interface. So if we now look at this from the capture point of view, we should see that router 2 starts to advertise that its directly connected interface is the source of the, or is the router ID for that, or not the router ID, but the transport source for that particular session. So if we say the IP.source is equal to 10.2.12.2, okay, that's the link between router 1 and router 2. So IP.source is equal to 10.2.12.2. And we look at the LDP hello message. Inside LDP, under the transport address, it should say that let's see, was that the right interface? That was on gig1.12. Show run interface gig1.12 is, no, 10.1.2.2. 10.1.2.2. Okay, when we look at the hellos for 10.1.2.2, it says the discovery address is 10.1.1.2.2. So in other words, it's the address that's directly assigned on that interface. What this is effectively doing is the same in BGP, is statically setting what the update source is. So by default, the update source is the router ID. The router ID comes from the loopback, hence your transport address is the loopback. But you can change this either by hard coding the router ID. So if we went to router 2 and said MPLS LDP router ID is loopback 0, and then since the process is already running, we need to say force, which resets LDP. And now when we go to the other neighbors and look at router 1 and say show MPLS LDP neighbors, it says now the identifier is 2222. Previously, the identifier was 22, but again, we didn't have a route to that. We had a route to the directly connected interface. Okay, other questions up to this point in terms of just enabling basic LDP, making sure that the transport is working, making sure that they form the adjacencies, and that they advertise the labels for the IGB routes that are installed. There's a question, so using the force command will cause a drop in traffic. Yes, that's true. Because when they reform adjacency, they have to renegotiate the label space. The label space probably will stay the same, but regardless, you still need to flush it out of the forwarding table and then re-add it back in. So even though it may be a short cause and drop in traffic, it will be a drop between them. There's a question, will graceful restart help with that? No, it won't, because graceful restart is only when you're doing a stateful switchover, like between your active and standby supervisors. To reset the router ID, that has to be a hard clear of the TCP session. So basically, in a real design, you want to set the router ID first before you turn LDP on. Then when they go to form the TCP adjacency, they're already using whatever identifier that you want. Now, within the scope of the lab exam, that doesn't really matter because we don't care about traffic loss. But in a real design, yes, like if you want to change the identifier, you need to do it during a maintenance window. There's a question, as I mentioned earlier, per session load balancing, is this the same as per destination? No, it is not the same. I'm not sure exactly what the command is offhand to change this. Let's see, what would this be? It would be, let me search for IPsec for MPLS LDP. Let me see in this platform, just in global, if there's a command. MPLS, I'm not 100% sure if you can actually change this. IP load. Let me check into that while we're later while we're on break, but by default it uses whatever the Ceph hashing is, so it's not the same as per destination. Ceph is typically doing per flow, which means that your source and destination TCP ports are going to impact how the load balancing decision is made. And notice previously the way that I had tested that was between XR1 and router 1, where I had configured multiple links between them. The destination address that I was pinging or doing a trace route to was the same. So the destination was 5555, it was router 5. But based on varying the source address, so if I trace from source is 11.11.11.11, the end result is that we use a different outgoing interface because the load sharing decision is based on the flow data, the layer 4 and layer 3 and layer 4 header, as opposed to just the destination, where the destination is the same in this case. It's both 5555. There's a question, the transport address should be available via the same interface as LDP hello packet arrived. Not necessarily, which means that there could be a problem then with the establishment of the adjacency. So what I mean by this is let's say that between router 1 and router 2, you receive the hello in this interface, but the loopback is routing this direction. It means that the TCP session won't go directly between router 1 and router 2, but it technically doesn't matter because the only thing TCP is doing is advertising the label numbers. When you do the switching, you'll always switch to the interface that the transport or hello came in on. So router 1 basically says, well, the UDP hello came in on gig 1.12. So for whatever label numbers that I receive from the neighbor, those are going to be associated with the outgoing interface gig 1.12 when I actually go to do the forwarding. Okay, there's another question. What does the addresses bound to the peer mean? This is when you look at the show MPLS LDP neighbors. The address is bound to the peer. This means that these are all of the interfaces that they can be sourcing traffic from. This is how they figure out that there's multiple links that are connecting between the same neighbors. So again, in the previous example, when we looked at between router 1 and XR1, I had the address 10.00.11 as an address that is bound to the peer. So when we go to the interface that is actually using that address and enable MPLS, and we look at the show MPLS LDP neighbors, it now means that I have multiple routes in order to reach them, because it's what are the routes that I'm using to reach their addresses. So likewise, if we were to take router 1 and let's say we add another subinterface that is on this link, so we connect router 1 that way, it means it would have 3 equal cost paths to label switch towards XR1, but it would be using the same label numbers out all of those interfaces. So the label numbers come from TCP, but UDP really controls where you're switching the packets based on where the hello actually came in on.